Okay, let's look at the homework one, problem number 6. Alright, so we want to use the ratio test to see if this series is convergent or divergent. Alright, so ratio test is works pretty well when you have factorial in the expression. Alright, so let's try that. So a ratio test. So we have an, so this is our an right here. Right, then an plus 1 would be, so an plus 1 would be, so every time you see n, we're going to replace it by n plus 1. So it's going to be 5 to the n plus 1, and then you have a square root of n plus 1 plus 1. So can I write it n plus 2? N plus 2 here, right? Then divided by n factorial, so you have n plus 1 factorial. Right? So we're gonna do a ratio test. So if we need to evaluate the limit as n approaches infinity, then we have an absolute value of an plus 1 over an. Right, so let's do that. So this is going to be, here's the limit as n approaches infinity, right? Then absolute value, right? So an plus 1, which is right here. So I'm going to put 5 n plus 1 square root of n plus 2 over n plus 1 factorial. Alright, and then you want to divide by an, right? So divide by an is the same thing as multiply by its reciprocal. So all I have to do is I'm going to multiply by upside down version of this guy. So we put n factorial on top, right? Then you have 5 to the n and the square root of n plus 1 right here. Alright, then you have an absolute value sign. Alright, so we should be able to cancel things out. Let's see, first thing is there's a 5 to the n, and you have a 5 to the n plus 1. So you have one extra 5 on top. So I'm going to just cancel 5 to the n. Then I'm going to just strike out the power so that I know that there's going to be 5 left on top. Alright, and another thing we can do is, we can rewrite n plus 1 factorial as, so I'm going to strike that out. It's exactly the same thing as n plus 1 times n factorial. Right? So we have n factorial on top, so you can cancel that, and you have n factorial on the bottom. But we still have n plus 1 left over. Alright? Then, so what you have is, let's see, so you're going to have this. So this is going to be equal to, so I'm going to go down here. Alright, so you have a limit Alright, then you have, let's say 5. So 5 is here, so 5 has nothing to do with n. N is going to infinity. Alright, so 5 is going to be out here. Alright, then you have, let's see, square root of n plus 2, and there's a square root of n plus 1. So I'm going to just write it as big square root, alright, and n plus 2 on top, over n plus 1 on the bottom. Right, so that will take care of, so we took care of this 5 right here, and we took care of this guy right there. Right, then we took care of this guy right there. Right, then we still need to take care of this guy. Right, so we need to put this is just on the bottom, so it's a 1 over, right, n plus 1. All right. And to make it easier, we can just rewrite this guy as this. Maybe I'll give you another line. So you have a 5 here. You have a limit as n approaches infinity, right? And you have a 1 over n plus 1, right? But this guy right here, we can rewrite this guy as square root of, right? So to n plus 2 over n plus 1 is 1, because you have n plus 1 here, then 1 extra. So it's a 1 plus n plus 1, right? Then it's clear that where this guy is going when n goes to infinity, right? So here, 1 over n plus 1. This guy goes to 0, because 1 divided by big number. And the same thing here. This guy goes to 0. All right. So what you have is really 0 times square root of 1 is going to be 0. So you have 5 times 0, which is, of course, 0. All right. Since 0 is less than 1, which means that you're going to have a conversion series. So conversion. Right, because ratio test is mimicking the geometric series. So this quantity is basically representing r, and the absolute value of r turns out to be 0, which is less than 1, which gives you a convergent series. All right, that's it. I hope that this was clear.